Good afternoon. Am I audible to you? Anyone, please? Can anyone confirm me whether I am audible or not? Then we'll discuss about solar energy today. Like what is solar power, solar radiation, solar constant, and the application of solar energy. First of all, like solar power. Solar power. Why it is required? So if you talk about the solar energy, can say it is the conversion of sunlight into electricity, or conversion of sunlight into electric power, either directly using that photovoltaics or indirectly using concentrated solar plate. If we are using that solar photovoltaic, that time it is known as direct energy conversion or direct solar energy conversion. Or if we using that concentrated solar plate, that time it is known as indirect solar energy conversion. Or the power produced by utilizing the solar radiation. The main thing, like the power produced by utilizing the solar radiation is known as the solar power. In brief, I'll be discussing here. And next, if we talk about the solar radiation. So this solar radiation is the radiant energy, that is the electromagnetic energy which is emitted by the sun. Solar energy is nothing but the radiant energy, it is the electromagnetic energy emitted by the sun. And there about half of the radiation is in visible short wave, okay, isn't it? Half of the radiation is in visible short wave part, and uh, the other half is mostly in the near infrared part, and with some in the like ultraviolet part of the spectrum. So the half part we are talking about, the half part or the half portion of the radiation is in the visible short wave part of that electromagnetic spectrum. No, will be from electromagnetic spectrum. And the other half part, so it is mostly near infrared part. So half part of that electromagnetic, there is the visible short wave. Okay, half part of the spectrum, and another half part is the mostly that near the infrared part. And some part that is there in the ultraviolet part of the spectrum. So this is the just very basic of this solar radiation. And if we talk about this solar constant, so it is the rate at which solar energy arrives or reaches into the Earth's surface from the sun. These things are known to you, very common. What is solar constant, solar power, solar radiation, solar irradiance. Uh, so here, what is the value of solar constant? It is no 13 it is 1353. Solar constant value is what it is 353 watt per meter square, isn't it? So it is measured by the satellite. So this is the rate at which solar energy reaches into the Earth's surface from the sun. And the major applications of solar energy is the following: the solar water heating, space heating, space cooling, solar pumping, solar cooking, agriculture and industrial process heat, then solar production of hydrogen, then solar energy, and that is we are talking about the thermal energy conversion. Then uh, in solar energy part, another one is photovoltaic electric conversion, photovoltaic energy conversion using that photovoltaic. Then uh, here for solar energy conversion system, their solar panel comes into the picture. So what is solar panel, or how to specify this solar panel? So this solar panel is you know, normally specified by some standard test conditions. So the status, test condition that is the W peak, the peak power. So here from the panel, how much of voltage can be generated, no? And how much of current can be generated from that particular panel. So that is known as the uh, that standard test condition. Like the voltage will the unit of voltage is V and current is I, and they are suppose voltage of having 2 volt it is possible to generate, and current it will be like okay, 2 ampere 2 ampere. Then what will be the power for the panel? So peak, so it will be 4 watt, isn't it? Voltage multiplied by current is nothing but the watt. So, like there are some standard panel, okay? Suppose for 40 watt, it is in peak condition, 40 watt panel. Why we are using that peak? Suppose like we are talking about the mileage of vehicle. So that mileage, no, that is uh, that is measured in standard test condition in that in the factory itself. So by using that 1 liter of fuel, how much kilometer or how much distance you can travel? It is the mileage. And here we measure the solar panel's capacity by its test condition, or like how much of power it can generate. Okay. Uh, so here for 40 watt 40 watt panel, the standard voltage is 18 volt and the current is 2.22 ampere. Okay. So it's the standard one. So but we cannot say like from the 40 watt panel we can divide it into like 20 volt and 2 ampere. So we cannot do this one from our own. There are some standards. Okay. So for 40 watt panel, this is the standard one. Okay. And like for panel, so here it will be B max, okay, maximum voltage and maximum current, because we are talking about the maximum itself. Peak is nothing but the maximum, no. So for 100 watt panel, the maximum voltage, the standard maximum voltage is 18 volt and maximum current is 5.5 ampere. And for 250 peak panel, the maximum voltage is 30 and maximum current is 8.4 ampere. Okay. So these are the some standard. And like how to purchase or what is the price for those kind of solar panels? Like in the market, we purchase potato per kg. We purchase tomato per kg basis. And here per kg is not the way. So how to purchase a solar panel? Here we can purchase the solar panel by its capacity. It is by its watt rating. Watt rating, rupees per watt. Like for small size or small quantities of that panel, its standard price is from rupees 25 to 30. From rupees 25 to 30 per watt. And for large size solar panels, so it's near about 20 to 25 per watt basis. So is the costing one. You can write it down. Note it down also. These are the some standard, okay? Yes. Then uh, how to identify the solar panel. No? The first one was the specification and the identification. Then that solar panel is identified by the technology. Okay, is identified by the technology. Okay, so there are like few materials which are generally used. There are mainly two types for this solar cell. Okay, first one we can say the silicon based technology. First one is silicon based technology and the second one is the thin film based technology. Okay? And, that silicon based technology uh, that is with higher efficiency. Okay? Efficiency is high, and for thin film based technology, the efficiency is comparatively low. And this one is flexible, and it's not flexible. It's not flexible, and that one under silicon based technology, that two materials are generally using the silicon based technology. One is monocrystalline and another one is multicrystalline solar cell. Or another one is okay. Then we are talking about efficiency for this solar cell also. So what does mean by efficiency here? Anyone? What the efficiency for solar cell? Anyone? What is the efficiency for solar cell? Yes. Here, the efficiency is nothing but the how much incoming light is converted into electricity. How much incoming light is converted into electricity. That is known as efficiency here in solar energy. Okay. Uh, so here figures are there. Uh, so these are which one is monocrystalline and which one is multicrystalline? Anyone can say here? This is monocrystalline, okay, and this one is multicrystalline. Multicrystalline one, and here no in this like silicon based silicon based thermal silicon based solar cell, the efficiency is for this no silicon based technology, the efficiency is no 15 to 18%. Okay, and here for the thin film based technology, the efficiency is 14 to 16%. Minimum is 14, maximum is 16. Okay. So here you might be thinking like efficiency is very less over here if we compare with that no wind power plant. But here in solar technology, the technologies are easier than wind turbine technologies. And here that capital cost is less also for this solar energy or solar power plants. If we are getting 15 to 18% efficiency, so that is fine. And there no like in coal-based power plant, that efficiency is only like 8 to 10%. 8 to 10% for coal-based power plant. Okay? For coal-based power plant. So if we compare with that coal-based power plant, here we are getting like very good efficiency. And here this is the one no sample of that the power rating of any no solar panel. Here the maximum power you can see no like maximum power that is 100 watt or voltage maximum voltage, and that is 18, and the maximum current or open circuit voltage, then short circuit current, that tolerance, maximum system voltage, everything are given for this one, okay? For 100 watt, for 100 watt solar panel. So generally this solar panel is specified this way. Okay, specified this way. So this is made in Gurgaon itself, Gurgaon, Haryana. So this is the one sample of that solar panel. And if we talk about the another solar cells, so here this is about that thin film. Okay, thin film. That thin film has having any size, and these are having some standard size. Okay, from here to here, like in this having some standard distance, and here no, there is no standard size. I mean, it's having no, it can have with any dimension. Okay, so here we can say like this is flexible one. Flexibility is there. We can roll it. We can carry it easily. But this kind of cells, we cannot carry it easily. No, as it is not flexible. That one, it's as it is not flexible. If we compare this one with this, that thin film based solar cell, and there, like no, you can make it any size also. There is with some standard size, it may be having like 6 inch by 6 inch or 1 feet by 1 feet, no, by cutting that fuel cells. Like you are going to use the solar panel there in your calculator, in scientific calculator. Then you can see there in the scientific calculator, that solar panel is very small. And if you are planning, no, for the power generation for your own home, there the panel size it must be large. Okay, so here you can say if it is full cell, this will be the half cell, this will be the half cell, and this will be the quarter cell, will be the quarter cell. So it can have no any size. Okay. Then uh, then how much area is required, how much area is required no, to produce some solar energy. Okay. How much area, how much area is required. So here no, some standard is there, like for no, 15% efficiency, 15% efficiency solar cell, there the area required, it will be no, like for the generation of 150 150 150 watt, we require 1 meter square area. So why I'm suddenly saying 150 watt? Why not 100? Why not 100 watt? Or why not 1 kilowatt? Because like here you just multiply it with 15 into 10. So then you'll be getting then 150. This is the thumb rule, I can say. Like if we use 18% efficiency solar panel, then there 180 watt power, 180 watt power we can generate from the 1 square meter area. Now you calculate. If you use 18% efficiency panel, as you'll be getting 180 watt from the 1 meter square area, then for the generation of 100 watt, 100 watt from 1 meter square area, how much efficient mm, how much efficiency panel is required. Okay, or or if we use this like you are having like 1.2 meter square area. from the 1.2 meter square area, how much power can be generated? How much power can be generated if you use like 16% efficiency panel? So you can find it out. You can calculate it. Suppose you are having like 10 meter square area at your rooftop. Then how much power you can generate? And if you use that, suppose 18% efficiency panel, so you can calculate this way. So just you calculate it. Suppose one another hint. Suppose your record is 1000 watt. Your power record is 1000 watt. Okay. Or 1000 watt is nothing but the 1 kilowatt. And there you'll be using 15% efficiency panel. Okay. Then how much area will be required? How much area will be required? And how to find out required area? How to calculate it? So how much you require is 1000 watt you require. And just 15% and then with 10. Calculate it. How much it is coming? 100 by 15. 6 point. Okay. 6.66. So you have to use 6.66 meter square area to generate 1 kilowatt power with 15% efficiency panel. Or no? So this standard you have to remember, okay? And this one and the previous one also. What is the efficiency of silicon-based solar panel and what is the efficiency of thin-based solar panel? For silicon-based, it is 15 to 18%, and for thin film, it is 14 to 16%. So those are the basics of this solar energy. Okay? And the other part we'll discuss in the next class, like what is solar life, solar panel life, how to maintain it. Okay. Then if we are using stand-alone, okay, or off-grid system, then we have to store the energy there in the battery. Then how to manage the battery, or what size of battery we have to purchase or we have to use. Then those things we'll discuss in the upcoming classes. So like in the last class yesterday, we are talking about the objectives and about the proper work plan. You prepared it? Have you prepared it? All the students, please unmute your mic. So one must not take this mini project in casual way. This is important one. All the students have to put, they have to give some valuable input here in this topic, here in this mini project topics. And I have seen like so many students haven't submitted that one, haven't submitted their summary report, and you haven't studied, you haven't gone through any paper also. 6 to 7 students are there. Must not take this one in a casual way. So preference must be given in this mini project. All the students, please unmute your mic. Cannot you hear me? I'm asking to unmute your mics.
Sir, our group is yet to start because we are having our final year project submission
Wait,
after this.
just wait. I'm asking to unmute mics for all the students.
Yes, sir.
So in the last week you were talking about that you are having gate. Now gate paper is also over. Gate paper is also over. Now you should work here. Okay. The topics given here as a mini topic, mini project topic. For the group, I must not say group 1, 2, but for the topic 1. Topic 1, there is no one. For the topic 2, group members of topic 2. Unmute your mic and other students can mute your mics. Group 2 for the topic 2. Yes. Have you prepared that one? The objective and the work plan? Yes. Yes. Aman Kumar Singh, for 2 no one is there. For 3. For group 3, roll number 7, 97, 102, 113, 123. Unmute your mics. Group 3.
Yes, sir.
Have you decided it? Have you prepared?
Actually, we had gone through 2 research papers related to that.
You have to report me by tonight. okay, group wise, all the groups, what you did, okay, no, regarding these topics. You have to mail me.
Okay, sir.
So anyone from the group. So here we will take responsibility from the group 3 for the topic 3. So group I'm saying in respect to that one, no, topic number. So the first rule numbers, like the group 3, it is started from 7, rule number 7, no. So Aman Kumar Singh has to mail me, okay, on behalf of your group, not from your individual one, but from your group, okay, on behalf of your group, what you did. And likewise, no, from all the groups, the first rule number, you have to email me regarding this work plan and the objectives. Dibesh, you got what to do?
Yes, sir.
So this way, and whenever you are mailing me, like you just, you know, in the subject, you just mention mini project topic on, it is the title. You just mention it. Okay? And now in the mail body, you just write the report kind of, or in the Word file also, you can write over there and put your names also, all the group members' name, the Word file and in the mail body also. Then you have to keep other members as CC. Whenever you are mailing me, like rogashukanda rate of mac.benedy.ac.in, and there you have to keep other students as CC. Like suppose Amon is mailing me, then Harshil, Priya, Utkarsh, Anshuman, they will be there in the CC. For all the students, we have to follow the, no, same system. And whenever you are updating in the next time, suppose you'll be sending the second email, just email here only. In the same email, no, you have to replay over there. The first mail, it will be the like some model email. So, or role email. This role model or role email, we have to follow it. So whenever you are sending another mail, you have to replay over here only. To send the email as a replay. So for all the students, you have to follow the same. Okay. And uh, the students who haven't selected the topic, you just email me individually. No? You just you must mention the reason behind. No? After 2 weeks also, why have not you selected the topic? And if someone is not updated there in the, no, student wise topic. Okay. In the student wise topic also, I can see like the rule number 4, the rule number 9, then the rule number 14, rule number 54, rule number 70, 90, 96. For 96, it is received. Okay. Then rule number 120. Okay. So just you email me the reason or the reason behind why haven't selected the topic and why haven't you updated there in the student wise topic. There in the
Sir,
page number 4.
I have actually updated my topic. I have
When?
taken group number 8.
When? After last date.
No,
Rule
sir.
number? What's your rule
Fourth,
number is?
fourth.
So you took time, I think, updated after last date.
No, sir.
I have no, actually I have not downloaded that one, the Excel sheet. downloaded the Excel sheet. That's why it's not came. Okay, I'll check it again.
Okay, sir.
Here,
Sir, in your Excel sheet, our topic is missing. Means it
topic
is
is
erased
missing.
by someone, sir.
How?
Sir, we
So,
don't know, but the topic is not present. What you have written there.
what was the serial number?
Serial number, I think, sir, 12. I just confirm, sir, and tell.
16.
16. Simulation and analysis of solar energy in electric vehicles. So there in the Excel sheet at the right side, you can see the one, see the screenshot. I pasted one screenshot over there. At least that screenshot no one can change.
Okay.
It is given. Here in the sheet number 4. In the sheet number 4, it is there. So for rule number 4, where you have updated this one? Student wise topic.
Just a minute. We are talking about that group number wise, right? But actually, my group member had updated my rule number.
So here I'll be sharing the Excel, that one spreadsheet. Can you see the spreadsheet?
Just a minute.
Anyone? Can you see it? Divesh,
Which
can you
one?
see it?
Yes, sir.
See here, rule number 4. Rule number 4, it is blank, no?
Okay, sir. I'll update it right now.
The update one. So why you are telling this way? You have updated?
Okay, that's this one is
How it is
update on.
okay? So see here,
Sorry, sir.
rule number 9, it is blank only. Rule number 14, it is blank. Then rule number 54, it is blank. Then rule number 70, it is blank. So I'll be downloading this one. That time it will be 12:55. So it will be the latest one. You then 96, it is blank. For 18 page, okay. For 18 page, I know the topics. Okay. I'll ask you in time, and today onwards, you can update the topic over here, because then they know I have given you time. Like if you know wish to reshuffle, then you could reshuffle that time. Now there is no time for reshuffling, then you just update the topics over here. 17 and 18 page students, and there the topics also you just mention it here also in the sheet number 3. Here you can write like 20, then 21, 22 this way. And here the student's name. So here in the where the screenshot is. The screenshot also someone has deleted, no? Hari,
No, sir. It is on the fourth sheet on the top.
is it on the top?
Yes, sir.
Correct,
Just
correct.
now.
You have seen. Yes, it is there. So do it, and the students who has not filled this one, fill it up. And regarding your objectives and work plan, decide it and confirm it by tonight. And now the topic is decided, and now onwards you can download the relevant papers from relevant papers according to your topic itself, and you can go thoroughly over that on that papers, relevant papers. And you must ensure that like no one is selecting any conference paper, or no one is selecting any page journal papers. The links are already given, and how to download that solar related paper, the links are also given. And some videos are also uploaded there, and videos as well as that video links related to that softwares also it is given. So you can refer that. And for wind energy prediction or wind resource assessment, so many papers are uploaded. Here you can see classroom. Can you see the classroom? So I use materials I have uploaded over there. Okay, you can refer the same.
Hello, sir.
Yes.
Gate mechanical is there on 13. Some of us are appearing for the gate. So can we do it after that?
Gate? Which gate you are talking about? Gate is over now.
No,
No,
mech-
sir. Actually, multiple subjects are there. Mechanical is there on this weekend.
Is it?
Yes, sir.
Yes,
It's not
Yes,
over for
sir.
mechanical. When the date is?
No,
13th.
No, sir. Mechanical is this weekend.
Date
13th.
13th.
13. So I hope all the students from third year they are not writing gate.
Some of third years are
Those,
also writing the gate.
those who are writing gate, it's fine for them. But those who are not writing gate, that student may be from final year or it may be from third year, they must update it. Or no, those who are preparing gate, it's not good for them. For gate, you can do this.
Okay, sir.
Okay then. No. Okay. I think Dibesh has taken the attendance.
Sir,
yes, sir, taken.
Taken. Fine.
excuse me, sir.
Yes, yes. If you are having query,
Sir,
then you
also
can be here, and the students who does not have any query, you can leave. You can talk. The students who are having some query or questions.
Sir, I've updated my roll
Fine,
number,
I'll
sir.
check it.
Okay, sir.
Yes.
sir, also 18 batch students are having our first BTech project submission.
When? When? It will be there. It is continuous work. No, all the work we have
Yes,
to
sir.
do. Parallel we have to do. All the work. So that's why it is given as group wise. No, in the group 5 students are there. So it's enough. Just divide your work. Someone will
Okay.
be someone will be preparing that objective, or someone will be studying some papers, or someone will be downloading. So distribute your work. Anyone? Any query? Doesn't have any query, then you can leave.